Hello everyone, I am Dr. Madhavi Kuncham, working as an associate professor in the Department of the Chemistry at Marri Laxman Reddy Institute of Technology and Management. Today, now I am going to discuss regarding one of the important topic which is also helpful in our daily life also, that is in the water treatment of module 1. Water treatment of the module 1 in the engineering chemistry. Under that, the one of the important topic is ion exchange method. Ion exchange method means why, what for ion exchange method is used. That is, in the water treatment, all the topic is related to the hard water which are having the ions, that is a salt, hardness causing salts temporary. In our earlier topic we got discussed about the temporary hardness causing salts, what are the temporary hardness causing salt and what are the permanent hardness causing salts, we have already discussed. So now in order to use this hard water both in the commercial as well as domestic purpose, we need to do the softening, means we need to remove the hard water from the hardness from the water. That is, we are going to make it hard water to soft water, right? So this is called as softening of the hard water. That softening of the hard water is having the different method. Now we'll discuss in detail about that. What are they? Now it is called as a softening of water. This is a softening. It is also called as conditioning method. Softening or the conditioning method of the hard water. Softening means removing the hardness causing salt and making into the soft water having only H plus and the OH minus ions other than the hardness causing salt. Right. Now, here conditioning is also, it is also called as conditioning, means by means of applying the different reagent, chemical reagent, water is converted to the soft water. That is why it is called as a softening or the conditioning of the conditioning methods of the hard water. Different methods we have to remove the hard water. So first, now see, let us discuss about this. It is mandatory to soften the water to make it free from the hardness producing salts. That is what we have discussed. Because in order to use it for both the commercial as well as the domestic purpose, we need to make it soft water. Means we have to remove the hardness causing salts. For that, we have the two methods, two ways we can do the processing or removing the hardness producing salts from the water can be done by the two methods. So what are these two methods? One is the external treatment, another is the internal treatment. So let us discuss about in detail about this external treatment as well as the internal treatment. What is the meaning of this external treatment and what are the different type of the chemicals are used in external treatment as well as in the external treatment and in the internal treatment. Now first let us discuss about the external treatment. External treatment of the hard water. The removal of hardness producing salt from the water before feeding into the water is called as external, means before. Now the importance of the water also we have discussed in the starting introductory class. That is, industrially, this water is used for the generation of the steam. In order to generate the steam, it has been sent into the boiler. So where the water is boiled continuously. If water is boiled continuously, it will produces, if it is having the salts, it will produces the scales and the sludges, and also so many troubles will get it. All the troubles we have discussed in the earlier classes, that is the scales, sludges, caustic embrittlement, so many troubles we will face when the steam has been generated. So in order to avoid that, the water is treated to make into soft, that is a hardness will be removed either before sending into the boiler or within the boiler also we can. If it is hardness, if the hardness causing salt, hardness is removed before sending into externally, outside only, it is called as external treatment. Means before sending into the boiler, the water has been treated, means hardness causing salts have been removed. That is called as external treatment outside the boiler the treatment has been done. Means hard water has been converted into the soft water before sending into the boilers. So now this is called as the definition you got. So you will get some idea about that if you know the definition. External treatment means before sending into the boiler, the water has been treated. Externally only it has been treated. So what are the different methods we need to follow as an external treatment of the water? Now, the removal of hardness producing salt from the water before feeding into the boiler is called as external treatment. Now, these are the different process: lime soda process, geolite are the permitted process, demineralization or ion exchange process, or like that number of the methods are there. In the one of the technique is ADT also there. That these are all the different techniques which are treated externally before sending into the boiler. So in that we were in detail, we are in this topic. We are discussing about the demineralization or the deionization, which is also called as ion exchange method. So what is the process involved in the ion exchange method we will discuss. Ion exchange process or demineralization or deionization. It is called as ion exchange process. Why it is called as ion exchange? This process involves the exchange of ions. Ions are nothing but cations and the anions. For the salts contains of the anions and the cation. So this process involves, in order to remove the hardness, the ions, cation as well as the anion has been exchanged with the resin which is used in that. It is called as ion exchange process. That is why now just I am discussing about the definition why it is called. Ion exchanging of the ion is involved, so that it is called as ion exchange process. Now it is another one is a demineralization. Demineralization, removing of the minerals, that is elements, minerals which are responsible for the hardness. That is why it is called as removal of the minerals present in the water. Deionization, removal of the ions. So that is why this is also called as ion exchange process, demineralization or the deionization. Let us go in detail about the process. Now coming to this process removes almost all the ions present in the water. It will remove all the ions present in the water, leaving only H plus and the OH minus ion. Soft water does not contain this Ca2 plus and Mg2 plus ions. Now, every soft water is not demineralized. This is a quote we need to keep in mind. Is not the demineralized water, whereas every demineralized water is a soft water. Demineralized water is called as a soft water, but all the soft waters are not called as a demineralized water. In this process, what we are getting are the demineralized water, which is soft we are considering. Ion exchangers are the resins with a long chain. These are the resins. Ion exchanges. In this ion exchange method, we'll use the ion exchangers. So what are these ion exchangers? Ion exchangers are the resins. These are the resin, means organic polymers. Organic polymeric resins which are acting as an ion exchanger with a long chain, cross-linked, insoluble organic polymers with a microporous structure, small porous, that is a small holes, that is a pores are present in the resin. Okay, so this is a cross-linked insoluble organic polymers with a microporous structure. Now, the functional groups attached to this. So, how it is working? How the resin is working as an exchanger means depending upon the functional groups which are attached to the chains are responsible for the for the ions exchanging property. Depending upon the nature, depending upon the functional groups which are attached to these resins. So depending upon the functional group, what type of the functional groups are attached to the resins which are responsible for the exchanging, now we'll see in detail. That is now see, these are the following two types of the resins are used for the demineralization process. The two types are the resins. What resins? As of now, we have discussed about the resins. The resins are responsible for the ion exchange. And what chemistry is involved in that? They are, how they are made up of? They are cross-linked organic polymer which are insoluble. And they are attached. So to that, the functional group which are attached to that are responsible for the exchanging process. Now we'll see that what are the two types. That they are called as cation exchange resin and the anion exchange resin. These two are called as cation exchange resin and the anion exchange resin. So what is this cation exchange resin and what is this anion exchange resin? What are the examples we need to discuss? Cation exchange resins. These are the cation exchange resins which are having the acidic groups. Such as COOH and SO3H. These are the responsible, having the H plus ions are responsible for the removal, exchanging of the cations of the water. What we'll send, we need to remove, make into soft. The cations of the water exchange with the cation of this. So that is why they are called as cation exchange resin. Having the COOH and SO3 like the acidic groups are present in the cation exchange resin. Now, cation is a hard water. Cations are the hard waters are exchanged. Cations in the hard water are exchanged with the H plus ions of this. That is what we are discussed. The H plus ions which are present in that. They are responsible for that. And what is this resin is called? This cation exchanger is made up of styrene divinyl benzene copolymer. Styrene divinyl benzene copolymer. It is a cation exchanger having the groups, acidic groups such as COOH or the SO3H groups which are responsible for the exchange of the cation of the water with the H plus ions of this resin. Now, so that is why it is a acidic functional groups are must for the cation exchange. Anion exchange resin which possess the basic groups such as OH or the OH minus or the NH2 minus groups. Basic group should be present on the anion exchange resin. And the example for the anion exchange resins what we can take are the phenol formaldehyde or the amine formaldehyde copolymer resin having the groups such as, functional groups such as OH minus or NH2 which are responsible for the exchange of anion of the water with the OH minus of the resin. Okay, so that is why they are called as anion exchange resin. Now, here this is the structure. Now, you can see the structure of this one having the groups like this. Now, here OH minus, this is anion exchange resin. It is a cation exchange resin which are responsible for the exchanging of the cation from the water and the anion from the, this is responsible for the exchange of the anion from the water. Okay, so these are the structures of the polymeric resins. Now, this is the diagrammatic representation of the demineralization process or deionization process having the, now see what and all will have. So, here it is having the 3 chambers. The column consisting of 3 chambers. Now, let us discuss about the plant for the ion exchange process. Here it is a cation exchanger and this is the anion exchanger and this is a degasifier. 3 chambers are present in the this cation, that is ion exchange resin chamber, that is anion exchange process. This process involves the plant consisting of 3 chambers. One is a cation exchanger, anion exchanger and degasifier. Just now we are discussing about the how it will be the diagrammatic representation of the plant. Now, this cation exchanger is connected with another container which is for the acid for regeneration, filled with the acid. Here it is filled with the acid. You may consider the HCl or the H2SO4 has been filled and is connected to the cation exchanger. Now, we will discuss why it is connected to this. This in the last of this topic after the process I will explain about this. And the anion exchanger also connected to the another chamber filled with the sodium hydroxide. cation exchanger connected chamber consisting of the HCl and the anion exchange chamber connecting chamber filled with the NaOH. Right. So the role of these two chambers will discuss in the coming, that is the next slides. So, and this is again, it is connected to the degasifier. It is connected to the degasifier having this one. Why all this? What the process involved in that we will discuss now. Now coming to here. Actually, now we are entering into the actual process of ion exchange method. The process of ion exchange method, here this process involves first step. First, what we need to do, that is the hard water is passed first to the cation exchange column. It remove all the cations Ca2 plus Mg2 plus ions which are present in the hard water, and equal what exchanging the cation Ca2 plus and Mg plus ions are exchanged with the from the water with the H plus ions of the resin. Now this is a reaction. Suppose here this resin is represented with a RH. This is resin. Now resin is represented with this. This is the hard water. Here it is a hard water. Resin, this hard water containing CaCl2, suppose if it is having the CaCl2 is sent into pass into the resin. Then what will happen? The Ca2 plus ions, cation, Ca2 plus ions of this will exchange with the H plus ions of this. These two will exchange, Ca2 plus and the H plus ions will come here. So that what will happen? It will form the HCl and the R2Ca, means cation is stuck. As earlier we have discussed about that, this resin is a porous, having the pores on it, small pores on it. So in that pores, the calcium or the magnesium is inserted, blocked into the resin, whereas H plus ions from that will go into the water. Like that, if it is having the calcium sulfate, it will form the outcome from the cation exchange is HCl, H2SO4 if it is having the CaSO4. If it is calcium nitrate, the output of the cation exchanger is a nitric acid. Now see this one, like this, both the calcium, magnesium salts. In that, if whatever the salt is present in the water, in that cation has been exchanged with the resin. Now see this one. Now coming to here, like this. Here, this is first what just now what I explained is that here the raw water, this is the raw water. Raw water means water consisting of the hard water has been sent into the first into the cation exchanger, cation chamber. Now this cation exchanger, it is filled with the, now here this is a resin. A resin has been filled into that. After that, a fine gravels has been sent for the filtration, smooth running of the water and the filtration, that is a gravel. And this is a resin. Here in this resin, if it is represented with a RH, the resin is represented with a RH. Now the water has been sent. Suppose water is having the CaCl2 is passed through this resin. When enter into this, having the pores into that, through these pores, the Ca2 plus ions will stuck in the resin. All the Ca2 plus ions will stuck into this resin. So what will happen? This H plus ions from here and the Cl2, the Cl from the water and H plus from here will go into this. So thereby in this outlet, the outcome of the water is a HCl. So the acidic water is coming out from here. Either if it is MgSO4, if it is MgSO4, magnesium is blocked here and sulfate will come outside. H plus and the H plus will come outside, and H plus and the SO4 gives the H2SO4. If magnesium sulfate is there, H2SO4, acidic water. Now this outcome from the outlet of the cation exchanger, the acidic water has been sent. The acidic water has been sent in passed into this, and this acidic water is sent into the anion exchanger, anion exchange resin. Anion exchange resin, this acidic water, suppose HCl is coming into this. anion exchanger, same thing. This anion exchange resin, this is a resin, and here this resin, it is represented with ROH, because if it is consisting of OH minus ion, and it is represented with a ROH, means if this ROH is coming, the HCl is coming from here. So what will happen here? This exchange of anions will take place, I said. This is a anion of this one, anion. This will come here and this will come here. So that what will happen? RCl plus here H2O, H plus and OH minus ion, H2O. So from this, the acidic water, as soon as enter into the cation exchanger, the anion of this will stuck into this, and the anion from the resin will come out, go into the water, so that it will come, that is a pure H2O will come from the anion exchanger. The pure form of the water has been coming out from the anion exchanger, so that this, as is, the water which is coming out of this anion exchanger is a soft water, demineralized, having no minerals in the water. This demineralized water has been, because of this, having the high demineralized or the deionized water is coming out from the anion exchanger. As this is having the high affinity towards atmospheric gases such as CO2 or the oxygen, it will react with that. As it is, if it will react with the CO2 or the oxygen from the atmosphere, it has affinity to, that is, it will causes the corrosion. Now we'll see this one. Now see, mineral acid and the anion, no, sorry. So okay, that is why it will be sent into the as high affinity towards the reaction with the carbon dioxide or the oxygen, which will cause is the corrosion of the boiler. That is why this has been sent into the degasifier, where it will remove all the gases which are reacted with the water. So completely pure water, deionized and the degasified water will be coming out from the degasifier. So like this process involves the deionized and the degasified. So water has been coming out, the pure water will be connected from this. Now here, see, these are the reactions involved in that, which are very, very important. You should keep in mind. Whatever the salt which is present in the water, that will react and it will form the HCl, R2Mg, like that. If it is magnesium is there, R2 magnesium. If it is calcium is there, R2. If sulfates are there, H2SO4 is formed. Nitrates are there, nitric acid is formed. And HCl is there, then HCl will be formed from the cation exchanger. Now, by this see, now, so these are all we are discussed, which remove all the anions like this and the water. Now, this is the reactions which are involved in the, now see this one. These are the reactions involved in the anion exchanger. Now from the anion exchanger, H plus ion and the OH minus ion combine to form. These are all we are just now we are discussed that all this, the deionized water or the get. Now see here, exhausted. The output water is also called as deionized water. After this, the ion exchanger get exhausted. Now see, what is the meaning of exhausted? See, suppose I'll be coming to this. Continuously, this is an organic polymeric resin, porous polymeric resin, I said. So what will happen in the case of the cation exchange resin? The calcium ions which are present in the water will block into the pores of the resin. When the pores, all the pores of the resin has been completely blocked with the cations, either magnesium or the calcium from the water, then see, if all the pores are blocked, then the resin is no more is possible for the exchanging of the ions, because it is not having any of the H plus ions for the exchanging. That condition is called as exhaustion. This exhaustion means exhausted. The resin, this resin is when completely filled with all the cations, then it is called as cations of the water. It is called as exhausted, resin exhaustion. Now this, like the same, anion exchanger also will be exhausted upon continuously using of this when the continuous use of this, what will happen? All these porous anion exchanger are filled with the anions of the water. So what will happen? It is no more ready to exchange with the anions. In that condition also it is called as anion exchanger exhaustion. So both the exchanger can be exhausted after doing some process. Means after continuously doing the process, they may chance of the exhausting, so that it need to be regeneration. Means the exhausted will be reused by means of regeneration. The process is called as regeneration of the exchanger. So this regeneration means, what is the meaning of this regeneration? Regeneration means, for that, now coming to this chamber, this chamber plays a role. When the now cation exchanger, now see this one, this cation exchanger are filled with the HCl, I said. As it is exhausted, this exhausted cation exchanger, when sent into the H plus as a HCl, hydrochloric acid or the sulfuric acid, upon passing, that is a washing of the cation exchanger with the HCl or the H2SO4, so that what will happen? All these pores have been regenerated, activated by means of removing. These washings can be collected after the regeneration. The washings will be sent into the outlet. Thereby, all the pores are opened, activated. Pores are activated, which removes, this acid will remove the calcium or the magnesium ions which are blocked in the pores, and will be sent into the, through these washings, it will be go out. Now it is regenerated. After washing with HCl, the resin has been regenerated. It is called as regeneration process. Like the same way, this regeneration of the anion exchanger can also be done by means of sending the, now this another chamber which is connected to this, it is filled with the NaOH. Upon passing the NaOH to the anion exchange resin, continuously passing into that needs a washing of the anion, exhausted anion exchanger, it will remove the anions which are present, anions of the water which are blocked the pores, so that all these washings have been sent through this pore, that is the washings after regeneration. It will be sent, and the here the exchanger is ready for the exchange. It is called as regenerated, means activated. Activated resin is ready for the further process, exchanging process. That is why these two chambers are used here. Okay, and this process is called as regeneration. Now we can see this one. These are the, now all the resin is filled with a, suppose Ca or to Ca, when washed with HCl, so that what will happen? Here it will form the Ca will be moved out in the washings, and RH will be there in that. Same the R2SO4 anion exchanger, sodium hydroxide has been sent, so that it will be removed and it will sent into the washings, and the regenerated will be the ROH and the RH. Regenerated, this is a regenerated cation exchanger, and this is a regenerated anion exchanger. So regenerated one, this process is called as a regeneration. Like this, we can regenerate and we can reuse further the number of ways. See, now the cation exchanges are regenerated by the acid or the regenerated. Just know what we have discussed, all this. This is the process of regeneration. Now, coming to the internal treatment or the internal conditioning, which involves the internal treatment. What is the meaning of internal treatment? Internal treatment is nothing but the adding the reagents. Treatment has been done within the boiler is called as an internal treatment. For the internal treatment, we need to have the follow the, these are the different, it's also called as a conditioning, I said. Carbonate conditioning, phosphate conditioning, Colgan conditioning, and the colloidal conditioning, and the EDTA conditioning. These are the different methods of the conditioning which are done by the internal treatment. Now, carbonate condition, scale formation can be avoided by adding the sodium. In the carbonate conditioning, sodium carbonate will be used in order to remove the scales. It is used only in the low pressure boilers. The scale forming salts like the calcium, if calcium sulfate is present in the water, it is responsible for the formation of the scales. In that case, by using the sodium carbonate, conditioning can be done. It is called as carbonate conditioning. Now, phosphate conditioning. Another type of the conditioning is a phosphate. Phosphate conditioning can be done by means of using the sodium phosphates. Sodium phosphates generally, now this phosphate react with the calcium and the salts to give the soft sludges. Now, see, three types of the phosphates are employed for the conditioning. Under the phosphate conditioning, three types of the sodium salts will be used. Trisodium phosphate Na3PO4, which is too alkaline in nature, and it is used for the too much acidic water. If the water is too much acidic, in that case, that is a highly alkaline Na3PO4 is used for the conditioning. Disodium hydrogen phosphate Na2HPO4, which is a weakly alkaline, only for the weakly acidic water. Monosodium dihydrogen phosphate NaH2PO4 acidic water used for the alkaline water. Now, that is about the phosphate conditioning. Carbonate conditioning, in that case Na2CO3, and the phosphate conditioning Na3PO4, that is sodium phosphate. In that, three different types of the phosphates have been used depending upon the nature of the hard water. Now coming to the Calgon conditioning. So what is this Calgon conditioning? What type of the reagent is used? We'll discuss. It is a Calgon is called as a sodium hexametaphosphate. Sodium hexametaphosphate. And this is a name, chemical name of the sodium hexametaphosphate. This interacts with the calcium ion from the highly soluble complex that prevent the precipitation of scale forming salts. So the complex, it will form when added to the hard water containing the calcium ions. Suppose for example calcium sulfate is present in the water. So in that case, it has high affinity to react with the calcium. That is, the sodium is replaced with the calcium. By this way, it will remove the hardness in that. So it will form the Na2Ca2PO3 taken 6 is soluble in the water, which is a soluble one. This calcium sulfate is insoluble. When treated with a Calgon, it will form the sodium calcium phosphate, so that it will form the soluble water, hence there is no problem of sludge disposal. So Calgon conditioning is better than the phosphate conditioning. In order to the removing of this wastage is also, sludge is also very easy. Now, colloidal conditioning. The colloidal conditioning agents, these are the colloids. In the case of the colloidal conditioning, that is, here the removal of the ions can be done by means of the colloidal formation. That is why it is called as a colloidal condition. So to form the colloidal particles, what are the chemical substance will be used? One is a kerosene, agar-agar, gelatin, glue. These are the substances which are used to make the colloidal particles. Now, they are used in the low pressure boilers. The colloidal substance convert the scale forming salts like CaCO3, calcium carbonate, calcium sulfate, which are responsible for the formation of the scales. So, they will convert this into the sludge. Sludge can be easily removed through the filtration. That is why the scale forming salts have been converted into the sludge, which can be removed by the blowdown operation by means of converting into the colloidal kerosene in that particle. That is, here the part it will make to the salt ions, the kerosene it will surrounds as a particle like a colloidal particle. So this is about the colloidal conditioning, Calgon conditioning. So these are the internal treatment. So that is what we have discussed. These are all about the internal treatment as well as the external treatment we have discussed now. For the softening of the hard water, external treatment involve the ion exchange method, which is having the cation exchanger, anion exchanger, degasifier. Water sent into the cation exchanger where it will remove the cations of the water like Mg2Ca, calcium or the magnesium will be blocked into the pores, and then acidic water is sent into the anion exchanger. From the anion exchanger, in that case, from the acidic water, that is acidic water, the anion will be blocked into the resin and the anion of the resin will be sent into the water, so that pure H2O will be sent for coming out from the anion exchanger. As it is a pure water, it has a high affinity to react with the gases, atmospheric, so it will be sent into the degasifier, where the deionized in the degasifier has been collected. This is about the brief discussion about the ion exchange resin method, that is external treatment. Now coming to the another way, that also we have discussed, internal treatment also we have discussed. And the internal treatment, we have discussed about the carbonate conditioning. In that conditioning reagent is a sodium carbonate, and the carbonate conditioning, next sodium, that is a phosphate conditioning. Sodium phosphate of the different types will be used depending upon the nature of the hard water. Colgan conditioning. In the colgan conditioning, colgan is used. Colgan is a sodium hexametaphosphate. This will convert the scale forming salts into the sludges of the water soluble sludge, so that it will be easily removed. That is the calcium has been formed. That is a colgan conditioning. Now coming to the colloidal conditioning, in that their colloidal reagents are the kerosene, agar-agar, gelatin, glue, etc. will be used in order to remove the scale forming salts such as calcium carbonate, calcium sulfate. Okay, so these are the important method, both the internal and the external treatment of the hardness causing salts. Now you can also go through these references. Through these references, you will get the more idea about the softening of the hard water, both internal as well as the external treatment method. Thank you. Thank you very much.